Okay, so after you've completed your do now, then we're going to start on the notes and we'll go through the do now later. But as you're going through this, just making sure for the do now, you are writing in your notes composition book and you're just analyzing this table. State the domain and range. So the independent variables are, dependent variables are, and explain why this is or is not a function to you. Okay. Now let's get started on our notes. So for your notes notations, you have choices here. You have the choice just to kind of write down the notes, or if able to print out the foldable that goes along with it and fill in the foldable. If not, either one is acceptable. Just writing them out in your notes composition. So the first thing we're going to talk about here is a set notation, discrete relation. So simply lists the input or output in braces, okay? So when you have a discrete notation, that means it's not continuous, it doesn't go on forever, but you have values. So for your x's and your y. When we look here, we have f of x equals this group of ordered pairs. So my domain are literally just the x values listed out in least to greatest order. So 2, 4, 6, 8. Okay. My range would be so my range would be 3, 5, 7, and 9. Simple enough. Let's continue with set notation. Also with set notation, I don't know what that shifted. When you have a continuous relation, so when you have a continuous relation, you are using a pattern. So you're using a combination of x such that, and then your inequality. Okay, and then again, they're within my braces are the worst in braces. Okay, so I'm going to read this as x such that. So when I look at my graph, my x values come all the way over here to -4 and they end at +1. So my x such that x is greater than -4, and notice I just say greater than because it's an open circle, but less than or equal to 1 because it's a closed circle. And I'm going to close off my braces. Okay. Again, on the notes, this was over there. I don't know why it's over here, but we're going to keep going. On my y is from bottom to top. So my lowest y value is at -4, and my highest y value is at 0. So my y is less than, greater than or equal to -4, but less than 0. And again, my braces. And that's my set notation. Okay, interval notation. So interval notation, we are including values and not including values. So, and we're using brackets and parentheses. Okay, so if I have parentheses or the strictly greater than or less than inequality, it means that the value is not included. Okay, or there's an open there, right? There's an open, a gap, some type of discontinuity exists. Okay, if I have less than or equal to or greater than or equal to, that means I'm using brackets, which means that it is included. And I forgot to take out the word. Or there's a closed circle there. Okay. When using infinity symbol, that means that we're going to always use parentheses. Okay. So whether it's negative infinity or positive infinity, we're going to always use parentheses. So let's try interval notation using the same example. Okay. Interval notation is used only with continuous / partial continuous relations for the most part, not discrete data, which is the list of data that we did in our first example. So we established that our domain, so our function's -4, +1. And so when I'm writing the interval notation, I'm going to pay attention to the fact here that I have an open circle at -4 and I have a closed circle here at positive 1. So open circles mean parentheses, and closed circles means bracket. And now I'm going to do the range. My range lowest value here is at -4, and then my range highest value is right here at 0. At -4, I have a closed circle, so that's a bracket. And at 0, I'm continuous. I go through. So that is a closed bracket. And this would be your interval notation. Now we're going to talk about function notation. So we often use letters such as F, G, and H to name functions, okay? So for example, the symbol f of x means plug the x in. Oh, well, plug in for x. I wrote that kind of weird. Plug in x. Okay? And we read it as f of x, okay? It does not mean f times x. It means f of x. So the function is dependent on x, right? And that's what they're saying there. So when you have just f of x, that's equivalent to y, right? And so writing this can be written as an ordered pair, and it's just written as your x comma your y value. Your input, your output. Your input, your output. So here we have this equation. It says y equals 2x plus 3, and we want to write it in function notation. So literally, all I'm going to do is substitute the y with f of x, and nothing else is changed. 2x plus 3, okay? So then you use function notation to evaluate that. So when I'm evaluating with function notation, where x used to be, it's going to become a 2. So we have f of 2 equals 2 times 2 plus 3 gives me 4 plus 3 gives me 7. So f of 2 equals 7. And as an ordered pair, it would be 2 comma 7. And that completes our function notation. Okay.